Good morning. Are we frozen? Let's see. Okay, here we go. Good morning. Technical things always last second, but that's what you have when you go live. So here we are. Thank you for another episode. And this time we want to get maybe a little more practical, technical, real world, what actually, Dr. Elvira does out in the field and what are the results of that. I know we've been having a lot more conversations already in the beginning of the year. People are like, okay, wait, exactly what do you do? Can you show me what it is? What are the results? So it's been so fun already, the beginning of this year, and how we can work to help uh, kind of figure out what exactly is going on in these very important systems.
Yes, so good afternoon, everyone. For me, it's already afternoon, and can't wait for the weekend. The year just started, and I'm just feeling that where are you Saturday? The same thing about the non-stopping hustle of the finding opportunities for the optimizations. Sometimes I feel that I'm not going to finish in this life talking about how the air is used, and probably I'm going to bring into the next life, and this wheel of samsara will never finish until actually everyone in the world will look at the point of use of their air rather than their supplies supply side, how it is generated. And I will not be tired, or maybe I will be tired on this life telling
Maybe.
that when you have your apartment, your house, you want to reduce the energy consumption, you don't first put a solar panel, you switch off the light. So please, let's switch off the light in compressed air industry and see how the applications is used. Today, I want to show you an old case that I already presented. I think I did it 2 years ago. It's very interesting audit because I was the moment when I was working as an auditor for the applications of compressed air, not in the as our esteemed colleague in the industry for the compressor room and the systems rather for the applications. I was hired as the fourth auditor coming into this factory to check what is happening with compressed air system. I did it with my colleague in Italy, and I just we prepared. It's very interesting case. I think we should make maybe some movies, and maybe Netflix will decide to make different episodes on that. But let's see. So today I would like to share with you this case because it started from the logic of the client that is right, continuing with the logic of auditors that also makes sense. But at the end, like Hercule Poirot stories that Agatha Christie wrote, the killer is actually another one, and he was always in the room. So let's look at this today and see who is the killer of our compressed air system, and a very short presentation. So let me share my screen. And this is so old, we even have an old branding, I think, here in this presentation. But do you see now my screen and the
Yeah.
presentation? Let me swap the modes
Yes. There we
like
go.
that. Okay, so steel manufacturing in Morocco. Here you see Moroccan dirham costs of compressed air. Very small here it's written, so the presentation, if you want to have it, I can send it to you. But where we actually started, steel manufacturing, so the cold rolling of steel consumes not so much energy, quite a lot. I would say 1,400, about 500 euros per year, 1,400 dirhams, and they use compressed air just for few cylinders. Really, surprisingly super small factory that I've been, and a very small distribution line, and so solely they use this compressed air for few cylinders. And then they have two machines where the metal sheets are rolling through this. They use compressed air for cleaning. So they had a lot of open blowing applications and open tubes. And then the maintenance manager said, wait, this is the last century. Let's replace it by engineered nozzles. So they called the uh, respected European supplier of engineering nozzles and blown applications, and they said, yes, let's buy for our air knives that have a way better performance than that. Wonderful. Client bought this air knives. So he found, and then after they installed it, the client investigation was that when the machine started to work, the pressure drop three or 4 bars. It's a huge pressure drop when we have a system with 6 bar. And you have 4 bar pressure drop, and something is wrong on this. So what client decided to do is investigate the system, what is happening. So they didn't call the supplier of air knives because they understood it's not their problem. So they called different auditing companies, gathered a lot of proposals, and got one of the not a very cheap proposal, not just from the one auditing company, but from the company that was providing the monitoring systems. So the company came from Europe. They spent 2 months on measuring. I don't know why they were measuring. You could see on the manometer the pressure drop of 3 bars, and the operator already was telling this. But they were measuring that. Okay, fine. So they measured, and then they had a very nice, fancy, schmancy, colorful audit that also is a good client decision because you have your roadmap, understanding what is happening in your compressed system. So they knew the consumption of the air, the total volume of the consumption, savings potential, question mark how it came here, because they had actually problem issues with the point of use of this and with the quality of the product. So we're going to talk about the savings potential when we have application issues. But anyways, so total cost of the compressed air, and then they also had an operational risks. So some dew points that are very low, pressure drops within the system when the system doesn't work. That is also quite when the system doesn't work at the point of use, but on the other points of use. 1.6 bar pressure fluctuation of 3 bar when the system starts to works. And what was the result of this was that, well, you need to repair leaks, probably redesign a compressor room to compensate the pressure drops, buy a new, more efficient compressor. This is where the cost potential came from, but because they had a quite an old compressor that already had to be replaced, and get a bigger receiver to compensate also the pressure drops. In compressor world, this kind of information makes sense. Get a bigger receiver, buy a new compressor if it has a very low performance, repair leaks, yes, monitor your system, and so on and so on and so on. Get a new efficient components. But then they invited another auditor who came with the more or less similar things, and then I was a fourth one after another also company, and then they asked us, help us to fix this, fix the problem. So I came, and the first point where I go is to see how the air is used, and actually talk to operators and ask if they are happy with the application or not. Because once you talk to the operator, no AI can actually come up with this idea how the air is used. So, and then the pressure drop can be confirmed simply by looking at the regulators close to the application. You will always have a pressure regulator with the manometer close to your application. Sometimes you don't need to install a very expensive monitoring system at the point of use. Just map your pressure. So map your pressure for the application. So by just looking at this and using amazing technology called eyes, we saw that the pressure starts dropping when the air knife starts to work. So then we decided to check the all other piping and how the air knife was made, from what is the ports and so on. So we got the technical data from the what is necessary to model and to calculate the consumption of compressed air at the point of use is always the geometry, so meaning the construction, so internal cavities and geometries that are filled by compressed air, and pressure level. That's it. You don't need to measure the temperature or anything else. It's another topic. But this is also in the basics of consumption of compressed air. And please also, for more information, follow us because I see that there are many questions on how to calculate consumption. But the what the air is consumed basically at the moment, you need to know where the air is going at the point of use. In where when it is a cylinder, you need to know the stroke of cylinder, the diameter. When you have the air knife, you need to know the orifices, the consumption, the geometry of this. That's it. You don't need to have a fancy schmancy things to model the consumption of this. After that, we calculate the consumption and we found the first pressure drop in the piping behind the machine. And then we saw what are the also the blowing forces. And then we wanted also to correlate it, of course, with the measurement. So we measurement and we see that things were fine. What we found out that with these pressure drops, if the customer wanted to have the same blowing force at the end, the summer blowing force forwarded, or the blowing application, they needed to have a 7.9 bars for at their compressor room, what they didn't have. In order to compensate all this pressure drop, they needed to put it way higher. And then we checked also the condition of the real application. The real application was that they actually had more pressure drops in other connections, and at the end they had a lower blowing force, not the blowing force of engineered, because they bought an air knife with a certain geometry that's supposed to operate under 5 bar or 70 psi. But because they had such a huge pressure drop within the system, the real output was they had then the 70 newton, the sum of the blowing force here, and this was way lower than they projected. This is why the operation was not happy with the quality of the blowing there, and the flow was also lower. And now we'll talk about it, why the flows matters. Once we so the production is super simple. Basically, they just bought 8 air knives, and they had 2 machines, and they just put 4 air knives to replace the open blowing. That's it. And what we found, of course, it was here you see just comparison, measurement, and model, but I can still continue that. You don't need the artificial intelligence to apply equations of compressibility and first and second law of thermodynamics. Basically, you can calculate the pressure drops, and it will really correlate with the real drops. And the leaks were there just 10%, and this is totally fine. And because we didn't model the leaks here, there is still a deviation in the pressure drops. So then what is the question was, what if we actually put these air knives and the way it is, and we keep the pressure fluctuation only 0.2 bar, and we check again the consumption for not just for one machine, one air knife, but the full production to deliver what was engineered before, deliver the blowing force that it was engineered before for this equipment. The compressor room had to have 12 bar. It's absolutely impossible. Have a huge amount of flow in order just to deliver, to push through this tiny piping connectors and so on. And the compressor consumption and cost would be, I don't know, like 5 times more than it was. Coming back to the initial idea is great. Customer had blown application through the open hoses, drilled pipes, and said it doesn't make sense anymore. Totally agree, and had a good idea to buy a good solution that is available on the market for that. So they bought this good solution available on the market. They found the material where it was written that replace open holes by engineering nozzles. Perfect. So they said that they have a 5.3 bar at their compressor room, and they bought the nozzles for 5.3 bar to install the point of use. Very good idea. So, however, the system compatibility have to be checked. As you see, it didn't go really well at the end. Why? Because the compressed air system was not engineered for this application. And here I don't want to go into the details about the various options, how you can replace the pipes, replace the connections, redesign the system. and to have the required pressure level, not installing a new compressor, not installing a bigger capacities. No, just reduce, you can reduce the blowing force. Maybe you don't need this even blowing force. And then basically model different applications on how we could save the situation. But then we actually asked client, why you need compressed air here? Do you need a cleaning with the high flow, but maybe the low pressure because you have a lot of dust here, and in this way you can have a low pressure application but with a higher flow for larger services? Or you need any precise cleaning where you really need the blowing force, so you need to have a high pressure but lower flow in the certain points. And this was the moment where we actually asked the process team what application you actually here need. At the end, they said that they need high flow application. It was not super precise there. They needed to have a high pressure application. And then was maybe you actually just put an electrical blower here. You have a huge facility here, you have a compressor room, a lot of tubing, and so on and so on. Maybe only for this application you put the electrical blower, and for other applications you leave your compressor system. And then basically this was the full calculation on how the situation still could be saved. And then of course it was I don't know if customers still did something or not, because this is what we how we finished the project. But the question is here is it feels like it's like no one's fault. Well, some questions to the experts and auditors that came there and didn't
Yeah.
see that. But the question is there again, how I use compressed air, for what I need it, for
Mm.
what I need this, and how it will be at the point of use of application. I don't say again, in this case, blower made sense, but in other cases, blower will not make sense. Simply because you have a better, for example, engineer nozzles, you have way more equipment there, you have cylinders, some other equipment. So it, from the ROI perspective of view, it will not make sense. But if you have an entire facility working only to push a huge amount of air through the teeny tiny rusty pipes that go first down and then up, and then at the end you have such a huge pressure drop because air is not water, we have a compressibility here. You at the end you have just like a little thing that you can put a person and just wave there around. It will be exactly the same than just paying $500,000 for that. So, and this is for me, I understand that I get very emotional usually about this. On first, you need to know how the air is used. It's not a really rocket science. So I always check the applications, and what is the first step is to do is the pressure mapping and the application mapping, where I have the point of use under what pressure this application works. So I have, and then you don't need to install the 100 million pressure sensors and flow sensors at the first. You just can see, go to the manometer uh, before each machine or each application. And thanks a lot for the pneumatic manufacturing that use this practice, that you have always the manometer that shows you the pressure. And then you see when the system starts to work, you see how this arrow of manometer starts to drop. And if it's just a little tiny drop, means it's okay. But if it doesn't goes like that, you don't need to install the pressure sensors and monitor for 2 months. This. So this is what I want to show you, that in this situation, the real killer was an application, and it was the how it was used. And it's really a detective. Every time, every facility you go, and you have a teeny tiny killer. And the thing is this: it's the compressed air system. They're connected. So you have the pneumatic part, you have a distribution, you have the compressor, and we always need to have a very systemic approach to that. So this is extremely important. And well, I hope in my next lesson and in my another lives, I feel like I will be still using this, because whenever I go to LinkedIn and then I see like amazing compressed air project. We install a super duper compressor that is more efficient. Yes, we need to always have more efficient components and be conscious about resources. But are you
Mhm.
sure? But without checking even applications, without even going into the opening the door to the production site and just sitting in the compressor room, it will not bring you anywhere. Will not bring anywhere. And today I just want to share this more technical case
Mhm.
that we had, and I think it's extremely important to really first see how it is used. And sometimes, and now people that work in pneumatic industry will throw me tomatoes. No, they will not, because I also see a lot of pneumatic manufacturing actually started to produce the electric drives, and we have also comparison and TCO. We did also one case study with Festo. So I did also my PhD on that. But there is always the limit where you use pneumatic or where you use electric drives. And you always need to see, do I actually need here 6 bar? Do I actually need here a nozzle or air knife? Do I actually need here what I need in order that I have my process? And the process that we use, it can be closing, opening something, it can be cleaning something, cooling, a lot of things. And compressed air is extremely, extremely useful thing. And when we say, hey, let's replace it, let's remove it, it's so costly. You cannot. It's like switch off the light in your home and don't use the heating. It's exactly the same thing. It's
Mhm.
the thing that you need. It is a veins of your industry. Find the way to use it more efficient. You will never electrify your process. You will never have because it will cost. Electric drives pay back within 6 7 years, and for so many applications you cannot even replace. So you cannot just start go and say, now I take just cold showers because I want to save warm water. Okay. It's not going to save anyone for that. So this is why I will always keep talking about this. Take care about the application. Go open the facility door and go and see how it is used. Blue pipes will lead you to that. Blue teeny tiny PVC pipes will lead you to the real killer. and and
Yeah.
then you will see the pressures, and then you will see also the consumptions. And at the first step you even just can calculate it yourself and understand what the real consumption is. So this is what I wanted to share today in our coffee and compressed air.
Yes. And I do want to add before we go, because I came from the exact other worlds with the nozzles and air knives. So this is like so close. But projects like these is what gives really good products. So the products can be amazing, high quality, really make a difference
Mhm.
for safety, energy, performance. But when the system is not correct, or if it's not the appropriate application, now that facility could be very skeptical, which a lot of them are, because this has happened at so many facilities. An engineer looks at one component and says, yes, let's bring this in. It's going to solve all of our problems. And then it doesn't, right? And then they become turned off. They become skeptical. They say, don't look at that machine because we tried to fix it one time and our production was ruined. This is the exact case of that. And then it can turn off. I mean, if I was the CEO of that plant, I'd be like, hey, stop messing with it. Like, it was working. Maybe like don't try to over engineer things. It can really turn people off, which is what holds us back and keeps the industry stagnant. And yeah, so this is the perfect case for that. Like, no matter how great the product is, if you don't understand what you have and it's not appropriate, it could turn so many people off.
Yeah.
And I've seen this a lot, especially on bigger capex projects where before we started working, you couldn't really see the whole how it would affect everything, but unless you stop production and implement it, and then by that time it's way too late, to go back and undo it.
Yeah.
So I think this is a very, very important episode because there are so many great technologies out there, and there are really, really good salespeople out there that have really great solutions. I've even run into some auditors who said they tried to explore new technologies and the wrong one was chosen and now they're put off. And I'm like, so what do you mean you're never going to introduce an engineered nozzle to anybody because the wrong one was chosen? So like this is so not good for our industry. It's not good for the end users, because when they are applied correctly, they can save hundreds of thousands of dollars and increase production exponentially and even make
Yeah.
the environment safer. So yeah, so this one really, really hit home for me. And I think a lot of people should look at this and don't give up. If you had an application, you tried it, it didn't work out, you're just missing some of these detective.
Just something is missing, of course. And also, how many I saw in the facilities engineered nozzles that were cut off. So I
Mm-hmm.
had I worked with some really big client and very respected that had created a roadmap, the books, the white papers for their facilities. They integrated all the engineered nozzles. Couple of years later, I was doing the application analysis, and then just come to the facility, and I see that they're all cut off. And then I say, oh, they're all cut off, and the energy manager would say, "Yeah, it's our operators. They are stupid." No, operators are responsible for the operation of that. So it means that somewhere happened something with the, and like he said, we just installed them and then they cut off like the second day because they're
Mhm.
really against the change. They're not against the change. Talk to operators, ask, are you happy with the quality of this? Because I saw that they had to blow this, and then it was a person who was cleaning by hand the end of the product after that. Thanks
Yeah.
God, it was not so precise. It just had to be clean. It's not like in the military or like in
Mhm.
other applications or electronic applications. But
Yes.
talk to them, involve the process people. Ask, what do you
Mhm.
need? Do you really need the flow or you need the pressure? So do you
Mhm.
need a high force here or you need just a something
Yeah.
that just blows everything around. So, and this is extremely important. Always go into the application side and
Mhm.
start from the point of use, and then check the distribution and supply. And I agree with you. There are so many good salespeople, and involve those solutions and
Mhm.
calculate them how they work all together, not just one single thing. Because I
Yeah.
also just a last also point um, I see a lot of people that sell the very good solutions, but they say that, and again, I was the same. I was doing I was not selling, but I was in the pneumatic system business, and I thought that if you integrate a cylinder that saves 50% of energy, it saves 50% of energy. Of course, then it was like 5% for the entire machine. But then I realized it was like zero for the compressor room. So at the end, or 0.1 for the
Yeah.
and recently, I had a conversation also on LinkedIn asking about the solution because it was written, our product saves 50%. And I asked, did you measure it in the application? For one application, application is one operation. Move,
Mhm.
push, blow, just one application. Call the point of use. One point of use, super local, open something, actuator or something, and I said, it's for the application, right? 50%. And it's totally doable. You have
Mhm.
solutions compared to the standard one that they use that save 90%. That it's
Yeah.
it's not a wizard thing. It's a very normal thing because the others one just oversized and don't make sense from the energy perspective of view, but they do their work. And then ask where it was measured. Is it for the machine? How many of those point of views were installed in the machine? Because I was looking for the efficient application for my project. So I couldn't find this. It was very specific. And I said, or it was measured in the compressor room. So I asked how many point of views was, how many production line was, what is the saving in the production line, what is the saving in the compressor room. So, and then he said me, both. It is the save 50% at the application and then at the compressor room. As an engineer, I close the conversation here. As a person who does the purchasing or who
Mhm.
does the engineering, I don't trust this because it doesn't make sense. If you have one point of use, you have one single cylinder that sells 50%, and you have only one cylinder in your production lines, and then you have 10 production lines, 10 cylinders that save 50%. and then you don't adjust anything else.
Yeah.
You will not see this. You okay, you will see a little bit of flow decrease in the production line,
Mhm.
but you have all other actuators. So you cannot say that you say the same thing in the compressor room, because it has to be in the systematic approach. So, and this is the other point for the salespeople. Please help your customers see the systemic picture. You can sell more. You can and sell, the word sell, I use it, thanks also to you, in a very positive way. It's a contribution to the production. You are helping people. It's sell smart your solutions. Don't tell that it's gonna save the world or that it's gonna save 90% of the energy, because it's okay to consume energy. So uh, show the systemic picture. Say that if you
Mhm.
install it here, you can have this and this and this, and then it will impact if you supply the supply set. Because unfortunately, why our industry is not moving forward very quick, as for example electronic industry, is that we're so fragmented, we're so not talking to each other and not checking the system completely, that in the end of the day, the development stopped because the end user, they don't trust. And because there is
Mhm.
no trust, there is no transparency, there are fragmented solutions, the efficient solutions are not sold. Simply, I see so
Yeah.
many companies that developed very interesting solutions and they cannot sell it
Mhm.
because
Yeah.
there is no trust in industry. So this is the moment for the end users, take the holistic picture, check it in the full system, and for
Mhm.
the salespeople, please help your customers to see the full picture. If you sell only nozzles, include it into the system model. We have system model. This is what we do. The whole model of the full system, right? The same thing also for auditors. So yeah, I can talk about this forever. So
I
really, I
know.
was
I
thinking
think we have like
it will go with me for the next for my next lives. I cannot finish it in this life for sure.
definitely not in 30 minutes. Um, okay, so I think this is a good ending point because, like you said, we can both keep going forever
Yeah,
on both ends. And like you said, it's not really anybody's fault. It's some of this stuff on paper should have worked, but there's so many moving parts in there that it's almost virtually impossible to do it by hand by one person. Luckily now technology and softwares and things have made it possible to do it. Um, but we're only in the very beginning, like very,
yeah.
very beginning. So
Very very beginning.
and we're going against this, skepticism already, on
Yeah,
both ends. So
yeah,
we have some work to do, but we will end there. I'm sure we have already from this episode the next 3 episodes that we could cover and keep branching off into
next
different.
33 episodes we can cover.
Yes,
Yes,
all of them. But thank you everybody
but
that joined.
for our listeners also. For
Yes.
our listeners, if you have, sorry to interrupt you, if you have specific questions, please DM us. And if you want to hear about something, if you want to invite some experts, or you want to come and explain your experience. So we decided to do monthly, have a guest for our compressed air, coffee and compressed air. So you are not so tired of both of us. So, but please bring it also. We want to grow this as the online representation of compressed air systems and pneumatic share experience here.
Awesome. Thanks everybody.
Thank you. Have a nice day and evening.